On this question, we want to use the periodic compound interest formula to answer the following question. How much money will you have in 6 years if you invest $18,000 at 5.5% annual interest rate compounded quarterly? And how much will you have if it's compounded monthly? So we want to use this periodic compound interest formula, which I have written down here. So this is the formula, A equals P times 1 plus R over N to the NT. And I've also listed what each one of these variables stand for. So the P is the principal or your initial investment. The R is the annual interest rate. N is the number of compoundings in 1 year. Now that word can be a little bit confusing, but what it means is how often your interest is added into the account. T is time in years, and A is the accrued amount. So I'm going to read my problem again, and as I read through the problem, I'm going to try to identify these numbers matching with these variables that we have. So in reading the question, we have how much money will you have in 6 years? So that 6 is referring to T, the time. If you invest $18,000, $18,000 is our initial investment, which is our principal. We're going to invest that $18,000 at a 5.5% annual rate of interest. So this is our rate, our interest rate, 5.5%. And when we use this value in our formula, we don't leave it in percentage form. We put it in decimal form. So we're going to take that decimal place and move it 2 places to the left, giving us 0.055 as the value we'll use in the formula. This annual interest rate is compounded quarterly. Quarterly is how often the interest is added into the account. So this is going to give us our value of N. If the interest is compounded quarterly, that means that the interest is added in 4 times a year. So N is 4. So we've got all of our values in the formula. We're going to substitute into the formula to get the accrued amount. That's how much money we will have after 6 years. So A equals 18,000 times 1 plus 0.055 over 4 raised to the 4 times 6. We're going to type our values into the calculator. This particular calculator will allow you to type the entire expression. We have 18,000. Let's try that again. 18,000 times 1 plus 0.055 over 4 raised to the 4 times 6 power. So we are going to have $24,981.20 at the end of the 6-year time period. Let's write that down. $24,981.20. Now, if you don't have a calculator like this, and you need to type in each individual operation. This is how you would type it. You want to make sure you follow order of operations. So you're going to start inside the parentheses, and you're going to do the division first, 0.055 divided by 4. We're still inside the parentheses, and we need to do the addition. We're adding 1. And exponents come before multiplication, so I'm going to do the exponent of 24 and then multiply by the principal of 18,000. And you can see we have the same value, $24,981.20. Now there is a second part to this problem. And the only difference on this part is that we are asked to compound monthly instead of quarterly. So this is only going to change the value of n. So we're going to change the value of n to be 12. We compound monthly, that is 12 times a year. Interest is added in. Everything else in our formula will be the same. 18,000 times 1 plus 0.055 over 12 raised to the 12 times 6. Let's bring my calculator back and we'll type that in. We have 18,000 times 1 plus 0.055 over 12. Excuse me, let me correct that. Divided by 12. And then raised to the 12 times 6. So this time we got $25,018.56. Notice I'm rounding to the nearest cents because we're talking about money. So we have $25,018.56. And you'll notice here that since we compounded the interest, since we added the interest more often, we have a little bit more money in the account because of that. When you do that, you start earning interest on your interest a little bit faster. So if you're able to compound or add interest in more often, your account will grow a little bit faster. Thank you for checking out my videos. Have a great day.